Hello again, everybody. This is I say everybody, no one's ever going to watch this. Anyway, enough about that. This is the third part of the bowling game Kata, which I've ported to C# and Visual Studio 2019. So this is the kind of walkthrough. If you want to just work out how to do it yourself, then there's a Github repository. If you search for Shaky Dave on GitHub, I'm sure you'll find it. I'll probably put a link in somewhere so you can get to it more easily than that. It's the internet, you know how to use it. So yeah, this is the part of the exercise where things start to get gnarly. And the reason for that is that, well, really it's because, well, let's make a start and we'll find out pretty soon. So, okay, so I'm about to start some work. So the very first thing I should do is run all the tests. They're all green there, but I haven't changed anything. However, in the real world, you'll maybe have pulled some code down from a repo somewhere. It's always good practice before you do anything. Just, is everything as green as I think it's going to be, so that you know that if anything goes red from that point on, it's because of something you did. So always a good thing to do. Okay, so yeah, let's make a start. So I've got my magic thing there, which I'll explain in a later video how I did that, but it just gets me some test code nice and quickly. So the reason things start to get a bit gnarly at this point is because we're starting to now delve into the actual rules of bowling and the complexities of bowling scoring, and yeah, it's not as easy as it first seems, and that's why actually bowling is a really good choice for something to build a red-green refactor test first development exercise around, because it kind of simulates what happens in real life coding, where everything seems like it's going to be easy to start off with, and then you get into it and you suddenly realize that the gnarly logic of real life starts intruding, and things start to get messy. So the first piece of mess is the idea of a spare. So a spare in bowling, for those that don't know, is when you get your 10 pins come down, and with 2 rolls you knock all 10 over. So let's do 2 rolls knocking all 10 over. So 1 of 5 and 1 of 5, just to make it very obvious that it's 2, and they make 10. So that is a spare. Not a swar, a spare. There we go. And then what happens when you roll a spare is your next roll counts double. So let's do a next roll. Oops. And we'll make that a roll of 3. And then, because it's me, so I've somehow flukily managed to get a spare, like the only one I'll ever get in my life, and then rolled another 3, and then I go back to what I normally do. So let's do 17 further rolls of 0, and actually I don't need to do that, do I, because I've got to roll many. That's what I want to do. That's what we did in the last one. Go and look at that if you want to know what all that's about. The code's just there, look. Oh, you roll 17. So I've done 2 loads of 5, so that's 10 for my spare, plus a roll of 3, so that's 13, plus the bonus, that counts double, so that's 16. Oops, 16, game.roll, no, score, there we are. So there we are, there's my test. Guess what? It's going to fail. This is red-green refactor, so this is the red part. Oh, doesn't work. Okay. So now we've got to write the code to make it work, to get to the green part. So as I say, this is where things get a bit gnarly. So what we have here is some code where the thing called score isn't doing anything to calculate the score whatsoever, and the thing called roll is actually calculating the score. So if you think about that just logically, that's wrong. That's what you'd call a code smell in the biz. This doesn't match what's the reality of the situation. it's always good to try as much as you can. You never will get to the full reality of a situation because this is computers and code and not real. And I could get deeply philosophical at this point, but fortunately for you, I'm not going to. But the reason why it's good to try and at least approximate reality as much as you can is that this isn't just your code. In the real world, if you're doing this for a living, other people have to deal with this. My current boss has a beautiful saying, which is you should always leave your code for the next person to find in a beautiful state, and the next person is a madman with an axe, and if he doesn't find it in that state, he knows where you live. So that kind of thing. So if we had a system where we kind of kept going down the road of score not really being score and roll doing loads of stuff that's nothing to do with actually just roll, telling the system what happened when a single ball got rolled, then the madman with the axe isn't going to be happy when he has to deal with this code later. So anyway, what we really know is this is all wrong. So what that means is our red here is going to probably take a bit of time to sort out. But the whole idea of red-green refactor is you keep things in the green for as long as you can. So you're going to do something which is only temporary and quite shocking, but oops, that's better. We're gonna comment that out because we know that test is going to take a bit of time to deal with, and let's just run them again to be sure. So we're back in the green while we try and get our heads around what we're going to do. This is part of the kata that some people struggle with as well. This idea that, well, I'm going to write some code which I know is wrong, and then I'm going to keep commenting it out, and then put it back together again and comment it out. Why don't I just write it the correct way to begin with? Well, it's because you're following an exercise. This isn't real. This is a kata. This is Karate Kid painting the fence. So we all know Mr. Miyagi didn't really need his fence painting. It was perfectly painted, and his car was nice and shiny and didn't need waxing, and that was all part of the film. He didn't have to do it. The only reason you'd really have to write a good bowling game is because you'd been hired to do so by Jeff Lebowski or something. That's unlikely to happen. So follow the exercise is what I'm saying. So comment the code out. Okay. So now we need to work out how we're going to maybe tackle the problem of getting the spare to pass. And as I say, the responsibilities are misplaced here. Score doesn't do score, and pins and roll does the scoring, and that's wrong. So what we actually want to do is kind of reverse that. But the way we're going to have to do that is with some global variables, or variables with global scope within this class, which both things can access. So what we need is an array to hold all the rolls in. Because it's global or has scope-wide access, we start it with an underscore. That's the kind of convention we use at work, but I think it's sort of used quite a lot as well. It's not just us. Okay, so we also need to track, where we are in the grand scheme of things. So that would be a current roll. Where have we got up to in the score generation? And then we actually want or maybe we want, spoiler alert, something to hold the score in as well. So what we've got there is an array. So unless we're careful, and will cause all sorts of errors because you have to actually properly instantiate those. Sorry for my big word, but so we want a constructor. There we go. Little shortcut there. Type CTOR, press tab twice, and we want to set the array up for the total number of rolls you would get in a bowling game, which could be up to 21, and that's because of the final frame. So remember I said with a spare, you roll 2 balls, you knock 10 over, then your next one counts double. So if you knock 10 over with 2 balls in the final frame, you've got to then have that extra roll in order to be able to get your bonus. Similarly, if you roll a strike in the final frame, you get 2 extra rolls. So the final frame can potentially have 3 rolls in it, hence 21. I'm using the word frame there a lot as well, you may notice. Hold that thought. Okay. So we've also got, okay, something where we have a global variable for score. So that can get set by that. And then what we also then do is add the pins that come in to the array. So we've got a track in our array of the score for each roll. But what we also want to do when we do that is increment the current roll as well. So we're working through the array one after the other. There we go. So set that with the pins that were knocked down for that roll. That's that one. So the other thing then is, as I say, score here is just a dumb thing that's just holding the score, whereas actually what we want to do is generate the score or manage the score. So we need to change that to a method that still returns an integer, but it will then use the array to calculate what the score is whenever you call it. So, so within here we want a local variable called score, and so it doesn't have the underscore on the front. And what you do is any point in the game you'd call that and it would know what was in the array, so it would work through the array and add everything up. So what the score is going to do is add stuff to the array, or add stuff from the array to the score. So you do so this is going to go in a loop, but as you know, I like to create my loops this way. So you put the thing that's going to go in the loop there, and then you do Control K, Control S, surround with a for loop. And that loop is going to loop the length of rolls. The sharp-eyed amongst you might see a trap emerging, but we'll find it ourselves in a minute. Of course, got a red squiggly there because we're not actually returning this yet. So return score. There we go. And that should make that go away. Okay, so that looks like something kind of more plausible. Score is now tracking the score, and rolls is just updating the array with all the roll data in it. What's going on there? That's interesting. Oh, Visual Studio is cleverer than I am. Okay, we'll come back to that. Okay, well, so here we go. Let's just try building this. So Control and B, because I suspect there might be something dodgy here. Well, I know there's something dodgy because obviously, but what you can do, actually, I want to do Control Shift and B to build the whole lot, because that built okay. But if I build the whole solution, Control Shift and B, I see some redness appear. So that's a technique that people sometimes call leaning on the compiler. So actually saying, well, I think there might be some problems with the code. So the very first quickest thing you can do is say, what does the compiler think is wrong with my code? Control Shift and B. Oh, look, it's found a couple of things that are wrong. And those are in the tests. I've changed game from a property to a method. So you need to call it as a method effectively. So there goes one of my problems, and there goes the other one. However, okay, now that will build. The red squigglies have gone and my errors have disappeared from down here. But if I run the tests, Control R and A, okay, no, that's fine. They're running okay. Oh, it's getting a bit ahead of myself there. Yeah, okay, well, Visual Studio told me I don't need that, so I can take that away. I don't really need that either. There we go. Let's just see. If you ever have code you don't need, you've got to take it out. There's too much code in the world. You know, our job is to reduce the volume of code. Yeah, okay. Okay, so that's that. So now let's do my test one spare. where have we got to? Is this going to pass yet? So control, if you've got commented out code, selected it all, control K, control U, and it will unselect it. Now I've still got the same error I had before because score is a method. So I just need to do that. There we go. Now let's run the tests. Okay, so that's failing again. But we kind of knew it was going to fail because we haven't put any of the actual generating a spare code in. So let's have a go at generating a spare, see if we can get that to go green. So spare is part of the generating the score, so it's going to go in the score method. And basically what I want to do is put some logic round the thing that's generating the score to track to see whether two things together make 10. So again, I can select that, Control S, Control K, Control S, surround it with an if, not that if. I don't know why that comes at the top. That's really annoying. I guess because it starts with a hash. So the alphabet says that. Anyway, that, if. Not that if, not a for, an if. There we go. If true, well, that's not very exciting, is it? So, but that gives me my place to actually put my logic. So I want to do if my current role plus the next role equals 10, then that looks something like a spare. Then you do, I want to add the value of the role after the next one onto the score to give me my bonus. But then I also, outside of here, then want to also just calculate the score normally in case, for all those things that aren't a spare. There we go. So that's my first stab at some logic for creating a spare. I've got two things that add up to 10, and then I'll add the one after that on, and then I'll just calculate the score normally as well. What does that do? Well, you see, that's broken everything. So that could have gone better, couldn't it? So my first stab at coming up with some spare logic doesn't really cut the mustard. It's sort of what I'd normally do in my day job, break everything. So got to have another go. Now the main reason, well, it's why is this breaking is a good question, isn't it? So Visual Studio will tell us, okay, index was outside the bounds of the array for all of them, and the reason for that is you're looking for roles I plus 2, but when you get to the end of the array, or even when you get to the end of the array with I plus 1 as well, then there's no array beyond that. So .NET kind of points out how stupid we've been at that point. Because again, I think most people would work that out for themselves before they even wrote it, but the tests are there to help. Okay, so yeah, we've got to do some more thinking. So again, we want to keep stuff in the green. So let's just not worry about this one. Let's just try and fix that problem first. So let's comment that one out again. See if we can get our other two to go back to being green again. Whilst not particularly putting it back how it was, we want to keep some forward momentum going here. So another part of the problem is this is just looking for any two that add up to 10. But that's not how bowling works. 10 pins get put down and you get 2 rolls to try and knock them all down. So if I knocked, I don't know, none down with my first one, like I normally do, but then knock 5 down, then I'd get 5 for that frame. That's the name for the 10 pins coming down and that kind of part of the process. Then if in the next one I rolled and knocked 5 down and then rolled none again, then my 10 would be spread across 2 frames. So I wouldn't get any kind of bonus because I hadn't knocked all 10 over. So we need some groups of 2, and that's what a frame is. So what we really need to do is start to introduce the idea of a frame. So what we need, a good place to put that is to put it there. And there are 10 frames in a game of bowling, so let's do that. So now our for loop is working through frame by frame. What I also want to do, we're not worried about the about that test that we've commented out yet. We're just trying to get those other first 2 working. So I'm going to take that logic out completely. But we still need to iterate through the score, sorry, the roles array, roll by roll. So we still need some form of counter for that. So I'm going to keep calling that I. Let's just call it actually something better. Let's call it roll index. No, I'm just going to call it I for the time being, actually, and we'll call it something better later on because it's red, green, refactor. Refactor it later. But we're doing it 2 rolls at a time, remember, because we're in frames. So you add that one to the frame, I, and then you also, or the score, sorry, and then you add that one to the score. There we go. Oh, I don't have to actually set I to something explicitly as well. There we go. So starting at the first one in the index, and then for each frame, of which there are 10, you add the first roll from that frame to the score and the second roll from that frame to the score. Then you have to move I on by 2. To move it to the next frame. There we go. Right. So I think that gives us a better, more bowling-like setup. And we'll see whether those tests pass. Yay, we're back to green again. So now we're back to green there. So let's have another go at getting this to work, because I think we're on a better footing to do it now. K and U, control K and U, and that uncomments it again. But we've taken the logic for actually calculating spares out. So let's have a go at putting that back in. Well, let's just run the test as well and just see where we are. Probably back to square one. Yes, so we're still not calculating the bonus. So let's get that back in there again. We want an if statement again. I'm just going to put it around there. So control K, control S. Not that if. Why is that at the top? It's so annoying. There we go. Okay. But we want the same kind of logic. So we want rolls I is the current roll plus the next roll. I plus 1 equal to 10. If so, you get 10 points because it's a spare. You've knocked 10 down. And then you get a bonus for the first one in the next frame, which is I plus 2. Oh. Just check the logic of that. That looks like spare logic to me though. So we know that rolls I is going to be at the start of a frame because we're incrementing it by 2 each time. So does this one and the next one add up to 10? Okay, that's a spare then. So the score is going to be 10 plus the one after that, which is I plus 2. Else. So it wasn't a spare, so we just have the normal score calculation that we had from before. Which is both the rolls from that frame, because we're going looping through by a frame. I plus 1, there we go. What do we think? Well, let's have a look. Great. So that is a spare logic. Doesn't really look like it though at the moment, because it's all rolls I plus 1 and roll out, and so our logic is kind of hidden in code. So this is stuff then that we can deal with. We've got it green now. Our test of 5 plus 5 plus 3 plus 17 zeros equals 16. That's passing. So that's spare is working. But this is a bit messy. We don't really know. Well, if we had to come back to this in 6 months' time, or in my case, if I had to come back to this in 2.5 days' time, I wouldn't have been able to remember what on earth any of this meant. So you can do stuff to the code to actually make it work a bit better, or make it a bit more understandable. So, for example, that's the logic for calculating if a spare occurred. So I've selected that now. I can do control and full stop or a period and extract a method. That's what I want to do. And I'm going to call it is spare because it's a Boolean result. So Boolean should always be a question, really. Is it a spare, or is spare if you want to be a bit more kind of programmy about it. Okay, so I've extracted that. That should appear down there. And has that broken anything? Well, I can easily check by running my tests again. Okay, no, still in the green. That's good. Yeah. Now, I mentioned I didn't like I as well, because I, what does that mean? So I'm going to rename I as well. Select it, control and full stop. Nope, not that. Select it. No, actually, I'm just going to rename it. Call it roll index. Okay, now I get those little dotted line around it, so I can now do this. Rename I to roll index. There we go. Did that break anything? It won't have done because Visual Studio did it for me. He says, yeah, and he didn't. Huh, thank you for not letting me down, Visual Studio. Okay. So that's the game code kind of made a little bit more understandable, but I can also tidy this up a bit as well. So I've got this comment in there. We don't like comments. No one ever reads comments. You go to university, everyone goes, oh, when you're coding, you must write comments so people understand what you've done. They won't understand what you've done because they won't read them. And also, people change code without changing the comments. And that's even worse because then the comments are telling you about stuff that, hasn't been that way for 6 months. So don't put comments in. Make your code more understandable. So I'm going to take that comment out because I don't like it. And I'm going to take my roll of 2 5s, and I'm going to do the extract method thing again, and I'm going to call it roll spare. There we go. Did that change anything? But at least I now know that's the logic of a spare. Two things that add up to 10. So you start to get some of the logic of bowling starts to find its way into the code, which is what we're after. Okay. So, as I say, a bit of a gnarly one this, but you've started to see how you sort of bounce your code in and out from red and green while you're getting your head round how the logic of 10-pin bowling works. Which clearly I struggled with at points, but it's all in GitHub, or you go to Uncle Bob and it'll explain it, or go and play 10-pin bowling for a bit. That's probably the best way to find out how 10-pin bowling works. Hopefully you'll be better at it than I am. Okay, there'll be another one of these. Oh, hang on, I need to commit what I've done, don't I? So I'm going to put adds test for a spare. There we go. Commit that. there we go. That's this one over. Next one in a minute. Bye bye.